Well, hello and welcome for session three, and in which I'm going to take up last three problems, which is begins with this that ABC non-real numbers दे दिए and non-zero real numbers दे दिए और a plus b plus c की value non-zero दे रखी है, and this show that this is true. So 1 upon a plus 1 upon b plus 1 upon c is equal to 1 upon a plus b plus c. So 1 upon a plus 1 upon b can be written as 1 upon a plus b plus c minus 1 upon c, और इसको अगर आप सिंप्लीफाई करेंगे तो you'll get a plus b upon ab, and that's equal to minus of a plus b, and which is equal to c into a plus b, something like that. ऐसा कुछ आ जाएगा बस, rather a plus b plus c. So either a plus b is 0, है ना, cancel a plus b, आप a plus b को cancel कर सकते हैं दोनों साइड से. And look, अगर a plus b is 0 then we are done, because just think about it. If a plus b is 0, then a is equal to minus b. And if a is equal to minus b, then and k is odd, then these two quantities cancel. And similarly, these two quantities cancel because a is equal to minus b and k is odd. So left hand side and right hand side are equal. Or what you get is, or अगर both true नहीं है, तो what you simply get is that ca plus cb plus c squared plus ab is 0. Right? कुछ भी नहीं किया, बस इसको simplify कर दिया यहाँ से यहाँ तक. So, well, if you do this, well, what we're going to do is that हम इन दोनों को club कर लेते हैं और इन दोनों को club कर लेते हैं. What you get is C. So C pull किया, what you get A plus C, and अगर यहाँ से B pull किया, you get A plus C again. So which gives you that A plus C into B plus C is 0. So either A plus C is 0 or B plus C is 0. And the analysis goes back to the same point कि अगर किसी भी दो का sum 0 है तो we are done with the problem, and we are done here, in fact, right? So that's that. In fact, this problem has got a very interesting history that I exactly this, मतलब the ये part, like got somewhere last year, and I discussed this with one of my friends, and I told him that I couldn't see a way, and then I made a recurrence to solve this, and I encourage you that you can make a recurrence to solve this problem, but it's not worth it. Like कोई worth नहीं है, because it's almost like boiling an egg with the help of a nuclear reactor. So that doesn't work. Okay, so over to problem number 6. And so before I begin, let me admit that I really don't have a, so to speak, nice solution to this problem, except that I'm going to just recommend on so many casework. अगर मेरे पास कोई एक अच्छा सा solution इसका निकल के आता है, तो I'm hoping that in the next few days I'll come up with the problem. And so what I'm going to do is that I'm just going to classify this problem mod 3, like mod 3 up classify कर लीजिए. So the ordered pairs that you will get is, so the problem says that n is a set of natural number, and these are 9 distinct n tuples. Show that there are 3 distinct elements whose product is a perfect cube. Perfect cube का मतलब simply ये हो गया कि first of all you agree that the elements will be of the form of 2 to the power ai and 3 to the power bi. So what you have to show is that there are some 9 में से कोई ऐसा होगा that a1 plus a2 plus a3 and b1 plus b2 plus b3, both of them are divisible by 3. Which fundamentally means that for me it was just casework and it's really long and complicated. So I'm just going to sketch the solution, not rather do it. But if there is one nice solution, I'll see, and if I can find one. So there's 1 0, there is 1 1, there's 1 2, and then there is 2 0 and 2 1 and 2 2. So nothing about it. These are the only 9 residues which are possible. जो residue possible है वो 9 है. And how do you begin? You can think of it that there are 9 numbers and 9 residues. तो या तो सब में एक एक हो जाए, और अगर सब में एक एक हो जाएगा तो we are done, because well, so many things happening. इन सब का sum is divisible by 3. इसका sum is divisible by 3. इसका sum is divisible by 3. In fact, आप किसी भी रो किसी भी कॉलम में अगर आप ले ले तो sum is divisible by 3. किसी भी diagonal के आप along ले ले तो sum is divisible by 3. And off diagonal के along आप ले ले तो sum is still divisible by 3. So which means that what you can't have is you can't have everything of one kind, and then you can't have three kinds of the same thing, because अगर तीन टाइप का सेम हो गया, we'll just multiply them and the thing is a perfect cube. Then comes the case, now this is where this gets really messy, which I'll just recommend that you should go ahead and do it, is that take this case that फिर जो चीजें होंगी वो दो दो होंगी, right? And then you have to make some examples कि अब दो कैसे आप लोगे. तो ordered pair could be, and I'm just going to write that ऐसा कुछ ले लिया आपने A1 A2, so A1 A2 A3 जो भी मैं लिखने वाला हूँ, there are going to be some permutations of 0 1 2. ये आपने दो ले लिया, से आपने कुछ ले लिया A2 A3, ये भी दो ले लिया. It makes sense कि आप अलग अलग लें, या फिर if doesn't make sense कि आप अलग अलग लें, you can begin with A1 A1, दो ले लो आप, A1 A2 दो ले लो, और A1 A3 आप दो ले लो, and then A2. Why? Because ऐसा हो सकता है कि that ऐसे नौ such cases बन रहे थे, sum it all. तो the worst case that you can do is that you can deny yourself कि भाई A1 plus A2 plus A3 is definitely divisible by 3, because मैंने बोला कि that A1 A2 A3 are permutations of 0 1 and 2. So the question here is that A1 plus A2 plus A3 नहीं लाना है, तो well, A1 plus A2 plus A3 नहीं लाने के यही सारे ways हो सकते हैं. जब इतना आपने कर लिया तो what is the next that you will take? So take anything A2 A3 जो भी आप लेंगे, and you will find something that adds up to uh, A1 plus A2 plus A3. आपको ऐसा कुछ आ जाएगा. In fact आप इन तीनों को ऐड कर देंगे, you will get A1 plus A1 plus A1 plus A1, which is 3A1, and we're done. So work out cases 9 of them, and you'll see that this is indeed true. Okay, so I'm leaving this here, and this is not an elegant solution because you have to work case by case, and this is tedious. So problem number 9, 7. So it says that consider a ball that moves inside an acute angle triangle along a straight line until it hits the boundary. When it changes direction, according to the mirror laws. So if there is mirror law, I'm hoping that Dr. Strange will come to our rescue. Just like a ray of light, angle of coincidence is equal to angle of reflection. Prove that there exists a triangular periodic path for the ball picture. First of all, जब ये problem आई तो I thought students who are well versed in physics, they have an advantage solving this problem. But when I tried this problem, then well, it sort of shattered my illusion, and I was like, yeah, ठीक है, like it's not really for not necessarily अगर आप physics जानते हो तो आपसे हो ही जाएगी. So what I'm going to do is that I'm going to show that since there's an acute angle triangle, I'm going to draw a pedal triangle. Pedal triangle is a triangle formed by foot of perpendiculars. So think about it. Draw a perpendicular here. Say that this is a perpendicular. Say that this is a perpendicular. And say that since they're concurrent, so say that this is a perpendicular. So say that this is A, this is B, this is C, and this is D, and this is E, and this is F. And so we'll not wait for it. So now look at this. ये देखो, like it becomes interesting because think about it. This angle is a right angle. This angle is a right angle. So this quadrilateral BD, whatever this is, it's cyclic. Q because this angle is a right angle, and ये angle भी आपके पास right angle है. तो ये वाला जो quadrilateral है, पहले मैंने गलत बोला था, ये quadrilateral की मैं बात कर रहा हूँ. This is cyclic, right? And so we can agree that this is cyclic. And since this is cyclic, because ये right angle है, think about it. ये right angle है, think about it. So which means that this angle is equal to this angle, right? And this angle is simply, so look at this. This is A. So this angle is simply a right angle minus A. So this is right angle minus A. And therefore, by this argument, this is also rather, this angle is also right angle minus A, because this quadrilateral was cyclic, right? Now, similarly, look at this triangle. Look at this quadrilateral. एक बार ये quadrilateral आप देखो. Uh, right angle, right angle, cyclic, and since this is cyclic, so therefore this angle is equal to this angle. And since this angle is angle A, so this angle is a right angle minus angle A because this angle is a right angle. And this angle is right angle minus A, therefore this angle is right angle minus A. So this angle is also right angle minus A, and we are done. So these two angles are equal, so angle of incidence is equal to angle of reflection. Since E and F are absolutely symmetrically the same points, so if the ball strikes F and E in the manner which I have described, कि foot of perpendicular के along टकरा के वापस आ जाए, so well, that's that, and we are done. So you see that it will obey the law of reflection, and this is a triangular loop. ये चलता चला जाएगा if it's a frictionless surface. So it tells you that the incenter of the pedal triangle is in fact equal to the orthocenter of the original triangle, and we are done. So the pedal triangle is the required triangle. At least it's one such triangle. It's entirely possible कि आप कुछ और निकाल दें. So that's that. Okay.